Hey guys, Mr. Moreno here. Really excited to be trying out this new technology. I have my hover cam here at home and hopefully this works. I'm going to be recording a lesson today for you guys. So as we go through the lesson, there's two things you're going to need. You're going to need a pencil and a highlighter. There's also going to be times throughout the lesson where I'm going to ask you to pause the video and complete some problems independently on your own. I will let you know when that time is. But for now, just anything that I copy down, if you can copy down as well or highlight, that would be appreciated. So we're going to go ahead and make sure that we're have our heading up at the top. So make sure we have our names. Today's date is, for most of us, it's the 11th of, what's today? The 9th. Okay. So the main purpose of today is we're going to be adding and subtracting like fractions today. As far as our objective, we want to be able to add and subtract rational numbers expressed as like fractions. We want to add and subtract rational numbers expressed as like fractions. Now today's lesson isn't too difficult. On Thursday, when we cover this more in depth, we're going to see, we're going to cover adding and subtracting unlike fractions. Continuing on, building on the essential question. At the end of this lesson, you should be able to answer, what is a simple rule for adding and subtracting like fractions? Spoiler alert, what is a simple rule for adding and subtracting like fractions might come back through on an exit ticket at the end of the class. So we're going to go ahead and begin. So the main topic of today is adding and subtracting like fractions. Now some words that will hopefully help us remember how to add and subtract like fractions are as follows. To add or subtract like fractions, add or subtract the numerators and write the result over the denominator. So if we have these like fractions, all we have to do is add or subtract only the numerators, and write that answer over the denominator. And this will make sense in a bit. For now, we can just leave it as is. Fractions that have the same denominators are called like fractions, which happens to be our only vocabulary term for today. So once again, fractions that have the same denominators are called like fractions. So we're going to do a problem together. But before we actually start diving into solving this problem, there are a series of questions here that are hopefully going to make us understand how to tackle not only this problem better, but as other problems as well. So let's look at the first question. Do the fractions have like denominators? Explain. Well, if I look at the two denominators, I notice that, yes, both denominators have the same number, which is 9. So we're going to write that down here. Okay. The second question I want to look at is, what is the sum of the numerators? Now, going back to our original definition, we said if we have like fractions, all we have to do is add or subtract the numerators. So in this case, I can write 5 plus 2 over 9. I can add the numerators, and I get 7 over 9. So the question says, what is the sum of the numerators? 5 plus 2 gives me 7. Now, my answer was 7 over 9. The question here says, how do you know the fraction is in simplest form? Well, it's simple. The only common factor of the numerator and the denominator is 1. In other words, the only number that can go into both numbers is 1. Lastly, we want to figure out why don't we add the denominators. 7 over 9 is my final answer, but I want to know why. Well, the denominator represents the whole. Okay, so for example, if you have the number 1, 1 would be the whole. We're adding 5 parts of one whole and 2 parts of one whole. The sum of these 2 parts is 7 parts out of the same whole, which means 7 out of 9. So that was our first example. The second example we want to do together is negative 3 over 5 plus negative 1 over 5. So the first thing I want to look at is, do the fractions have like denominators? Yes, they do. They both have 5. The next thing I want to ask is, do the numerators have the same sign? Negative 3 plus negative 1. So let's write that as negative 3 over 5 plus negative 1 over 5. So do the numerators have the same sign? The answer is yes. Both of the numerators have a negative sign. Yes, both are negative. Okay, the second question asks, what is the rule for adding integers with the same sign? So we're going to go back to our integer addition rules that we learned at the beginning of the year. If you are still struggling with these integer addition rules, you need to come see me or look online for some tutorials and refresh your memory, because these will keep coming back over and over again. So what is the rule for adding integers with the same sign? So the rule is, we add the absolute values and then keep the sign. Or, as the song goes, same sign, add and keep. So in this case, we have negative 3 plus negative 1. Same sign, we add and keep the sign. 3 plus 1 is 4. We keep the sign as negative and we write it over the denominator of 5. Therefore, the rule is, same sign, add and keep. The last question says, will the sum be negative or positive? Explain. Well, it's going to be negative because both of the add-ins are negative. So because I'm adding a negative number to a negative number, the answer is going to be negative. And I just want to remind you guys, at any point, if you feel that I'm going too quickly, or there's something that you didn't understand and you want to go back and rewind the video, you can. That's the beauty of how we're doing notes right now, is that you can go at your own pace. If I'm going too quickly, then you can go, simply just keep going at the pace that I'm sorry, if I'm going too quickly, you can slow down the video, pause, rewind. Or if you feel my pace is good, just follow along with me, okay? So that's the beginning of the first page. Just a lot of basic concepts being taught. The second page is going to require a little bit more independent practice on your part. So go ahead and turn the page to the next side. And you'll see at the top it says, got it? Do these problems to find out. So there are 4 questions here that I would like for you guys to complete. I want you to add and write each of the answers in simplest form. So at this point in the video, I want all of you to pause the video and take a few minutes to answer each one of these questions, A, B, C, and D, by yourself. When you are done completing the questions, all 4 of these, you can go back and click play on the video, and you can see my complete solution of how I solve these questions. Or if you are extremely stuck and you've tried the problems, or you're struggling on 1 or 2, once you're done and you feel like you've gone as far as you can go back and watch the video again. So please pause the video now. Okay, hopefully you paused the video. We're going to go ahead and work each problem out one by one. So letter A says 1/3 plus 2/3. So I notice that both of my denominators are the same, therefore I can add the numerators. 1 plus 2 over 3. 1 plus 2 gives me 3 over 3. And I can simplify this by dividing 3 divided by 3, which gives me 1. Remember, if you were to write 3 over 3 as your final answer, it would not be correct because it has to be written in simplest form, which is what I did here. Letter B says -3 over 7 plus 1 over 7. I notice that both of my denominators are the same, therefore I can add the numerators together. Notice what I'm doing. I'm actually putting the negative sign that's right next to the divisor symbol up here in the numerator. Now I'm doing this because it just makes it easier for me to understand what sign the numerators have. Now, although technically -3/7 is the same as -3 over 7, I like writing it like this when I'm adding the numerators because it makes it easier to figure out what's negative and what's positive. So -3 over 7 plus 1 over 7. I consolidate, or I put the numbers together, -3 plus 1 over 7. Okay? And then I use integer addition rules. I notice that I have different signs, which means I subtract. 3 minus 1 is 2, and I take the sign of the number furthest away from 0, which is -3. Therefore, I keep the sign as -2 over 7, which gives me my final answer. Now, if you write it as -2/7 with the negative sign next to the divisor symbol, that's also okay too. It's just more of a matter of preference of which way you want to write it. Okay, let's go to letter C. -2 over 5 plus -2 over 5. So I notice that both of my denominators are the same. Therefore, I rewrite the problem by putting the negative sign in the numerator for each part, like so. And then I write the numerators together. -2 plus -2 over 5. Same sign, add and keep. 2 plus 2, 4. Keep the negative sign, -4 over 5. My answer, -4 over 5. As a reminder, if I'm going too quickly, please pause the video or rewind at any point. The last question is letter D. -1 over 4 plus 1 over 4. I'm going to rewrite the problem as -1 over 4 plus 1 over 4. I notice that I have the same sign, therefore I add the numerators together. -1 plus 1 over 4. -1 plus 1 gives me 0 over 4. 0 divided by 4 is 0 because anything or any number divided by 0 always gives us 0. All right, now that we've done a few problems together, let's go ahead and work on a word problem. So we're going to do this one together. Number 3 says, Sophia ate 3/5 of a cheese pizza. Jack ate 1/5 of a cheese pizza and 2/5 of a pepperoni pizza. How much pizza did Sophia and Jack eat altogether? So the first thing I want to do with this problem is get my highlighter out, and I want to highlight what the question is asking for. How much pizza did Sophia and Jack eat altogether? Now, before I actually solve anything, I want to go ahead and figure out what is the question being asked, what am I being asked to determine. So I'm going to go ahead and write what I'm being asked to determine, which is how much pizza Sophia and Jack eat all together. The amount Sophia and Jack ate together is what the problem is asking for. Now, before I solve anything, notice I'm not solving anything yet. Right now, I'm trying to wrap my head around this problem and determine what is it that's asking for. So continuing on, what keyword indicates the operation to use? Well, the only keyword that tells me whether I should add or subtract or multiply or divide is the word altogether. So we're going to say that altogether indicates addition. So now that I know that I need to add or I need to use addition, I can go ahead and take each of these fractions and add them together. So we're going to write this as 3/5 plus 1/5 plus 2/5. Now, you don't have to write the parentheses like I did. The reason why I wrote the parentheses is because 3/5 refers to Sophia, and 1/5 and 2/5 refers to Jack. Now, even if I didn't have the parentheses, I'm still going to get the same answer, but just to kind of group the fraction parts together, I just thought it'd be easier to write the fractions as they are here. So we're going to keep 3/5 is the same, 3/5 plus. Now let's add these two numerators together. 1 plus 2 gives me 3/5. 3 plus 3 gives me 6/5. Now if I change this to a mixed number, I get 1 and 1/5. 5 goes into 6 one time. The difference between 6 and 5 would be 1/5. But that's not my final answer. Because it is a word problem, I have to write the answer in a sentence format. Therefore, Sophia and Jack ate 1 1/5 pizza all together. So now that we did this problem together, I want us to be able to try to do this problem by ourselves, this next one. It says, Eduardo used fabric to make the 3 costumes. He used 1/4 yard for the first, 2/4 yard for the second, and 3/4 yard for the third costume. How much fabric did Eduardo use altogether? At this point, please pause the video, work the problem out for the next couple of minutes, and when you're complete or you're just stuck, come back to the problem and see how I completed it. Please pause the video now. Alright, hopefully you paused the video, and now you can check to see if your solution is correct. So, just like before, I want to go ahead and look to see what is it the problem's asking me to do. It's asking me to find out how much fabric did Eduardo use altogether. So now that we know that altogether means to add, I want to write each of these fraction parts in a number sentence. 1/4 plus 2/4 plus 3/4. Now, I'm actually not going to write any parentheses here around any of the fraction parts. The reason being is because they're all referring to the same person, Eduardo. So we're going to leave it as is. Now, because I have common denominators, I want to go ahead and add all the numerators together, add them up to get 6/4. Now, I want to change this into a mixed number. So I'm going to divide 6 by 4 to get 1 2/4. 4 goes into 6 one time. The remaining difference is 2, and I keep the denominator the same. But this isn't simplified all the way. I have to simplify 2/4. I'll simplify that to 1 and 1/2 because 2 divided by 2 is 1 and 4 divided by 2 is 2. To complete my problem, I need to write the answer in a sentence. Eduardo used 1 and 1/2 yards of fabric. And that's all there is to it. So even though the problem is a word problem and it's a little bit lengthier than the other problems, you're still doing the same process, the same procedure. So at this point, go ahead and turn to the next page. And let's do this next problem together. So we've been focusing on addition of fractions with like terms. Right now what I want to do is focus on subtraction of subtraction of fractions with like terms. So we're looking at this fraction here. Same thing goes as before. We look to see if the denominators are the same. In this case they are. They're both 8. So what I want us to do is to figure out, is the first fraction a positive or a negative? Well, looking at this first fraction, I notice that the negative sign is in front of the fraction. Therefore, it is negative. Now here's the problem. We have a subtraction problem here. Okay. Now when we were teaching, when I was going over adding integers, those are the rules that we want to use mainly. But sometimes we get these subtraction problems here. Now, hopefully you remember this. The concept of adding the opposite. So we don't want to have a subtraction problem here. What we want to do is change the subtraction problem to an addition problem. Now, how do we do that? We do that by adding the opposite, which means to change the subtraction sign to an addition sign and make 3/8 negative, or the opposite of a positive 3/8. So we're going to do so now. Negative 5/8 stays the same. However, I add instead of subtracting, and I take the opposite of positive 3/8 and make it negative 3/8. Now, this problem becomes exactly what we were doing in the previous problems. It's pretty easy. We add the numerators together. Negative 5 plus negative 3/8. Same sign, add and keep. I get 8, keep the negative sign over 8, and I simplify. Negative 8 divided by 8 gives me negative 1. Now, this question says, how do you know that the sum will be negative? Well, I know that because the sum of two negative numbers is always negative. The sum of two negative numbers is always negative. All right, now that we know that subtraction is basically the same as addition, let's do this next problem together as well. Find 5/8 minus 7/8. Once again, I look to see, do I have common denominators? The answer is yes, 8 and 8. So the question is, can you subtract 7 from 5? And the answer is yes. I can do 5 minus 7, which gives me negative 2. Now, although this is correct, you can't subtract 7 from 5 using this rule. I like to add the opposite to make it easier for us. So just like the previous problem, we're going to add the opposite. We're going to keep the first fraction the same as 5/8. We're going to change subtraction to addition. And then take the opposite of positive 7/8 and make it negative 7/8. So the next part, we want to go ahead and look to see, do we have different signs? So we take 5 plus negative 7/8. Once again, integer addition rules, different signs, subtract. 7 minus 5 gives me 2, and I take the sign of the number with the greatest absolute value, or the number furthest away from 0, and I get negative 2 over 8. However, I need to simplify this fraction. I divide both the numerator and denominator by 2 to get negative 1 over 4. So this question says, rewrite the numerators as an addition expression using the additive inverse. So what it's saying is this. This is what the question is asking. We take the additive inverse. We change the subtraction problem to an addition expression, which is what we did earlier. 5 plus negative 7. So notice all I'm working with is the numerators. So now that we've done that problem together, let's see if you got it. Do these problems to find out. Letter E, letter F, and letter G. Work on these problems for the next couple of minutes. Work to the best of your ability. If you are finished with these 3 problems or you're stuck, go back to see how I completed the problems and check your answers. Go ahead and pause this video now and come back when you're ready. All right, so hopefully you did pretty well with these questions. They're relatively easy. So we'll start with letter E. I notice that I have common denominators, which means I can subtract the problem as is, the numerators. So I can write 5 minus 2 over 9. Now I know technically I can add the opposite in this situation by making this 5 plus negative 2. But since 5 is bigger than 2, I can just subtract like I normally would in a regular problem. 5 minus 2 gives me 3 over 9. And I can simplify 3 over 9 by dividing 3 by 3 and then 9 by 3, which gives me 1/3. Letter F. Negative 5/9 minus 2 over 9. So just like before, I look to see, do we have common denominators? And yes, we do. Therefore, I can subtract the numerators or add the opposite. So I'm going to rewrite this problem as negative 5 over 9. Now, let's add the opposite. Let's change subtraction to addition. Let's take the opposite of positive 2 and make it negative 2 over 9. And let's add the numerators together. Negative 5 plus negative 2 over 9. Same sign, add and keep. Add 5 plus 2 to give me 7. Keep the negative sign and write that over 9. My answer is negative 7 over 9. And last but not least, we have negative 11 over 12 minus negative 5 over 12. I notice that I have common denominators, which means I can subtract the numerators. Negative 11 over 12. Let's add the opposite. The opposite of subtraction is addition. The opposite of negative 5/12 is positive 5 over 12. Since I have common denominators, I can add the numerators together to get negative plus 5 over 12. Integer addition rules. Different signs subtract. Take the sign of the number furthest away from 0, which is negative 11. I get negative 6 over 12. However, I need to simplify this. Let me divide 6 by 6 to get 1, and 12 divided by 6 to get 2. Keep that sign the same. I get negative 1/2. So hopefully you did pretty well on those 3 questions. We are almost done. You guys are doing great. Let's go ahead and go to the last page. Now this page is mostly word problems. It's not too bad. We're going to break them down pretty easily. So choosing an operation. Now in a normal test, you're not going to have me telling you, okay, in this situation you need to add, or you need to subtract, or this is the section for adding, or this is the section for subtracting. It's all going to be mixed together. So it's going to be your job to determine what operation should I use. So in this situation here, we're going to determine whether or not I should add or subtract to solve real world problems. So let's do this one together. About 6 1/100 of the population of the United States lives in Florida. Another 4/100 lives in Ohio. About what fraction more of the US population lives in Florida than Ohio? So the question is asking us, what do you need to find? Well, let's highlight this last part here. Basically what it's saying is we need to figure out what fraction more of the United States population lives in Florida than Ohio. Now, here's a key word here. About what fraction more? Okay, that's telling us that we need to take the larger fraction and subtract the smaller one. Fraction more. So we're going to write the population of Florida as 6/100, and then subtract the population of Ohio, since it has a smaller fraction, as 4/100. I notice that I have common denominators, which means I could subtract the numerators easily. 6 minus 4/100 gives me 2/100. However, I can simplify this further. What number goes into both 2 and 100? The answer is 2. 2 divided by 2 is 1. 100 divided by 2 is 50. Therefore, about 1/50th more of the US population lives in Florida than Ohio. So now that we did this problem together, let's go ahead and see if you can do this problem by yourself. A picture mounted on an artboard is 1/8 inch thick. The frame for the picture is 5/8 inch thick. How much thicker than the picture is the frame? So please pause this video and come back to it when you are ready and completed the problem. Okay, hopefully you paused the video and you worked on it. So the question is asking, how much thicker than the picture is the frame? So let's highlight this. So you got this picture inside this frame. The frame is bigger than the picture. Therefore, we're trying to find the difference between the picture frame and then the picture. So we're going to write the fraction for the frame. 5/8 minus 1/8. 5 minus 1 gives me 4/8. Common denominators, I keep the same denominator. I simplify 4/8 by dividing 4 divided by 4 to give me 1. 8 divided by 4 to give me 2. 1/2 an inch. So the frame is a 1/2 inch thicker than the picture. So we're going to write that as the frame is a 1/2 inch thicker than the picture. All right, so hopefully you guys did pretty well with this. In a little bit, you'll be taking an exit ticket to demonstrate your understanding of the material that we've covered. Now, since this video is actually going to be uploaded to the internet, or it is on the internet right now, you can watch and view this video at any point. So if you're still stuck on this tonight or you're working on your homework, you can rewatch either all the video, parts of the video, half the video, whatever makes your little heart content. Decide which parts you want to rewatch, especially if the test is coming up and you want to review. This is a good way to review. So thank you guys for listening. Hopefully this all made sense.